Hi everyone, and welcome back to another exciting 6th grade math lesson. Today we are going to talk about evaluating algebraic expressions. Before we get started, we should really look into some of the vocabulary you're going to be asked to see. As you can tell in our title, there's a lot of big words being used. So the first word is evaluate. So evaluate means to simply solve. So when we're asking to evaluate, we are asked to solve the problem or to find the value of. So what it's worth. The value, not the best pen. Let me grab a different paper real quickly. There we go. And I'm back. All right, to solve or to find value of. So if you're asked to evaluate, you're really looking for like an answer to something. So if you even wanted to write the answer down, you could kind of do answer. Right, the next part, so that's what we're doing today. We are going to be solving, finding an answer to algebraic expressions. So the next part is, what is an algebraic expression? An algebraic is simply a math phrase that consists of numbers, letters, and operations. And we have done numerical expressions up through to this point. Numerical expressions are just the numbers and the operations. 3 plus 2 times 5 to the second power. All of that would be numerical expressions. Algebraic is when we throw the letters in there. So what is a letter? Why are we dealing with letters? This is math, Mrs. Meyer. Isn't math just all numbers? What are we doing with letters? Oh no. Don't worry, it's really kind of a fun concept. A letter in math is called a variable. A variable is a letter. It could even be any kind of symbol that just basically represents something that we don't know, like an unknown number. Or it could even be a number that keeps changing in an equation, so we can just keep putting in different numbers and using that same equation over and over and over again. So a variable is a letter. Sometimes it could also be a symbol that you use to represent a number that you don't know at the time. The last thing we have to be really familiar with is our operations. We just got done with order of operations, so it should be really easy to remember that operations are when we add, when we subtract, when we multiply, and divide, and those are our basic operations. Exponents, things like that. Dot, dot, dot. All right, so the last thing we want to look at, and this is huge, this is what's going to change a lot in the math we're going to be looking at, are the different ways that we show multiplication. And we've already been kind of showing you some of those new techniques, but it's really important now. We're going to be using them, and you're going to be seeing things a lot. Multiplication is tricky, so there's a lot of different ways to show multiplication. So we can do the traditional way. When we started off the school year, we did something like 2 times 3. So we used the crisscross X for multiplication. And then you also saw us start going to and using a dot 3. And we learned that that also means multiplication. We start getting away from the X because we talked a little bit about how the multiplication symbol, does it look like a letter, a variable that we'd be familiar with? Yeah, it looks like the letter X. So we don't want to confuse the operation with the letter. In fact, X is a very popular variable used in writing expressions. So from this point on, no more X's. We're going to use the dot is completely acceptable. And we do tend in math to get even lazier. You could also see it written where we don't have the symbol at all, and you have a number written down, and maybe the next number is in parentheses. So there is a number next to parentheses and there's no operation in between. This means that you are multiplying 2 times 3. And then the next one you're going to see now that we are using variables is, again, we leave out the multiplication symbol altogether. I'm going to use the letter N. and this would mean 2 times n. So if there is a number in front of a variable, and this number, for those of you who had the pretest, this is called a coefficient. So if you're wondering what the coefficient is, it's the number that's attached in front of the variable. Coefficient, they kind of collaborate together, they coexist together, all those other great words. So this really means 2 times n. So these are all the different ways to show multiplication, and you're really going to be being thrown into seeing this a lot, okay? And even now seeing this, you might be like, oh, I saw that on the pretest. That meant multiply? Oh man, that's okay. Now we know. Piece of cake, pretty easy once you know all the little secrets. Division, we've seen division before. We don't, in algebra, we don't use this symbol a lot. It's still there, but a lot of times we use the fraction symbols instead when we do a lot of the algebraic problems for no particular reason. But this symbol is still used, our traditional, line with the 2 dots. But you also could see it written as a slash mark, that kind of a fraction, 6 divided by 2. And then, of course, 6 and the fraction bar going straight across like that, 6 over 2. Is a very popular way that we write fractions or doing division when we're doing our algebra. And this just simply means the same thing, 6 divided by 2. Work your way from top to bottom. All right, so those are the important new little tricks that we are going to be focusing on. This foldable is really simple. It just gets folded in half. And then when you open it up, oh, lovely. When you open it up, you find out that it is backwards. Sweet. All right, flip it around. Easy solution. And let's take a look at how do we evaluate. So before we get into our directions, I want to just kind of show you something. We are going to evaluate an expression. Ooh, it got super big. So we're going to look at 2x plus 3y. So one thing we learned about is, what do we do again when it says 2x? Do we just combine the 2 together? Is there an operation that goes in there? What did we just talk about? Go back and look at the front of your notes. Do you remember? What happens when there's 2 things next to each other and there's no sign in between? It's multiplication. All right, so secretly, these are little multiplication signs right in here. If you feel like for a while you need to add them in, great. Eventually, you're going to get into the habit and you're not going to have to worry about putting them in there so you visually see them. You're just going to know it's 2 times x plus 3 times y. So I wanted to show you something. So why do we have the variables? We have the variables because maybe I want to use this equation. I go to the movies and a ticket costs, each ticket I buy costs $2 and popcorn costs $3. Or, I don't know, let's do popcorn costs $2 and soda costs $3 or something like that. Okay. So what we're doing is, what happens if I want to buy more than 1 bag of popcorn, or what happens if I want to buy more than 1 bag of, or more than 1 drink or soda? Speak it. Get it out, Miss Meyer. We can keep the equation and just keep replacing the x's and the y's with different letters. So it's really kind of simple. So let's just take, for example, where did I put them? Here they are. Let's say that in place of the x, we are going to put the number 1. And in place of the y, let's put the number 2. So what does that mean in our movie theater scenario? Okay, again, we're going to say the x means our popcorn. So how many bags of popcorn am I going to be buying? I'm going to buy 1 bag of popcorn. So that x is just simply going to replace the x in the problem. So what do we really have here? 2 times 1. So what do you think we're going to do with our soda, our drink, our y? How many drinks am I buying? 2 drinks. And where is that going to go in our equation? We're going to take it and actually put it in place of the y. And now that we know, 1 popcorn, 2 drinks. In fact, that's exactly what I order when we go to the theater with my husband. We share our popcorn and we definitely want our own soda. So let's take a look at what the final answer then would look like. This looks pretty easy. Looks like a little order of operations, Mrs. Meyer. Oh, yes, it does, Mrs. Meyer. So let's go ahead and do that order of operations. So we know multiply before we do any adding or subtracting. So we're going to do the 2 plus 1, or 2 times 1 first. 2 times 1 is 2. And then we're going to add. And you can feel free to bring down the rest of the problem like we were trained to do when we did order of operations. Okay, the next step is to continue with multiplication before we do addition. 2 times 3 is 6. Bring everything else down. And our last problem is 2 plus 6 equals 8. So how much would I be spending at the movie theater if I bought 1 bag of popcorn and 2 drinks? I'd be spending $8. Oh, but then all of a sudden someone new came up and said, oh, but I would like to join your group. And maybe it's my children, and they're like, oh, Mom and Dad, but we want also. So, maybe we have to change our 1 and 2. Maybe now I need, let's say, 2 bags of popcorn and 4 drinks. Because there are 2 kids in my family. We each like our own beverage, but we don't mind sharing the popcorn because we know we get free refills. So what's going to happen in this new problem? Did the cost of the popcorn change? No. Did the cost of our drinks change? No. But what changed was what we're ordering. So we're ordering now 2. So we're going to put our 2 in place of the X, 2 bags of popcorn. And we are ordering 4 drinks in place of our Y. And there's our new problem that we can solve using the exact same format. 2 times 2 is 4. Bringing everything down. We multiply before we do any adding. 4 times 3 is 12. Bring everything else down. And finally, 4 times 12 is 16. Now we're spending $16 at the movie theater. So that's really what variables do. It helps you keep the equation the same, but gives you an opportunity to change up how many. And that's all the X and Y's are. Just plug something in and you're able to come up with the answer. So hopefully that makes a little bit more sense as we go on to our next page in our foldable. So let's continue. So let's evaluate. Here is for our notes, what we're going to be filling in. So we are going to start off with substituting, replacing. We're going to substitute in the values for the given variables. So we're evaluating 9x plus 6y. So I see there's a 9 and an x together. What does that 9 and x mean we're going to be doing? Multiplying, that's right. Okay, so it's actually 9 times x plus 6 times y. And in place of the x value, we're going to put the number 2. And in place of the y, we're going to substitute the number 4. So we're going to substitute in those values. So we're going to substitute what for 2? Or x? Oh, there I go, I said it. 2 for the x and 4 for the y. So this is going to go 2, 2, 2, 2 right there. And this is going to go 2, 2, 2, 2 right there. Pretty simple. Just like taking the little, my little post-it notes. So the next thing we're going to do is we're going to rewrite this expression. We're going to rewrite it so we get rid of the x and the y variables so we can actually solve it. So now, if this is now, the x is now a 2, we're going to put a 2 in place of the x. And notice I put the little dot to represent multiplication to remind myself this is 9 times x plus 6 times, and this y is now the 4. So that's what my problem looks like now. So all I have left to do is evaluate the expression using my order of operations. So I'm going to put my numbers back in. Now what did I do? Do you notice the dot has disappeared? What did I use instead? I used the parentheses. It still means to multiply, but it's another way that you can see it. It means the same thing when it starts disappearing. So let's solve it. 9 times 2 is 18. And then we can multiply over here real quickly. 6 times 4 is 24. because we do all multiplication before we add. Now we can add these two numbers together. 18 plus 24 equals 42. So when x equals 2 and y equals 4, my answer is 42. So now you can see that evaluating is